Okay. Hi, my name is Josh,
And I'm Michael.
and this is our final design review for our EEG system for EE449 by the Workin Gherkins. So let's talk about what we're going to discuss today. We're going to be going over the individual components of our system, the instrumentation amplifier, bandpass filter, PWM circuit, IR receiver circuit, the alpha and beta filters, the PCB, and then we're going to show you our final circuit, scan chart, and PC and perf boards. And then we're going to demonstrate how it works. So let's talk about the instrumentation amplifier first. We actually had some trouble in the beginning with our instrumentation amplifier due to not using rail-to-rail op amps. We used the LM358Ps, and then we switched over to the LMC6484 and LMC64H2.
The only difference between those two chips is the package size. Yeah, we do create a VREF using the 200K ohm resistors, and those allow us to have the reference voltage throughout the rest of the transmitter circuit. Right, next, we'll be talking about our Chevy Chef bandpass filter. Not too much to say about this one. We use the analog filter wizard to create it, and then just set it up in the circuit between the instrumentation amplifier and the PWM generator. Speaking of the PWM generator, this is our circuit for it. We ended up changing this quite a bit throughout the quarter, but we ended up with a voltage range and a frequency range that we were happy with. It ended up being about, I think, 8 volts peak to peak, and then also had the about 1.2 kilohertz.
And connected to that is the photodiode that transmits over the PWM values over to the phototransistor, and it's being driven by the PWM circuit. Originally, we didn't have that 5.6 kilo ohm resistor that you can see, and we realized it was not driving our currents correctly in order to get the right output. As we were saying, with our output, there's also the input. So this is our receiver circuit. The current source with a resistor and NPN transistor that you see is actually simulating a phototransistor, as I just mentioned, and that is going into that op amp and forming our output voltage that you can see simulated right there. So we also have the alpha and beta circuits. Now, these were originally made as both of them would be third order systems. We revised this to be second order for the sake of simplicity, testing it on our perf board, etc. We have the alpha circuit centered at 10 hertz, with the beta circuit centered around 17 hertz, as you can see in the Bode plot on the right. And it's driving a LED to flicker / have a brightness intensity with respect to whichever filter is outputting at its peak.
All right, next is our PCB. This was made, and then we discovered we had a bunch of errors in our transmitting system, so it wasn't actually fully implemented into our design. That being said, we kind of just took all of the transmitter circuitry and put it on the PCB, added some ground planes so that it would help with noise rejection and stuff like that, but we did not end up using it in the final design.
Here you can see our final circuit schematic, at least the transmitter side, all on one page. This is so that you just understand how that system works. And as we've mentioned, it all works using that 4.5 volts as a VREF / ground in our system. And alongside that is our receiver side of the system, comprised of the alpha and beta filters, the receiver circuit, and an additional 4.5 volt source using that voltage divider with a 9 volt battery.
All right, here are our final PCBs and perf boards. The leftmost, the red one, is the transmitter PCB or perf board we got working. The middle one is the PCB that doesn't work for the transmitter, and the rightmost one is our working receiver perf board.
Now, just a bit of commentary on the system as a whole. The one on the right has that upward integrated circuits due to the header pins not allowing the IC to go into them properly, so we have to compromise with that. Also, here's our final Gantt chart. We were able to get all of our systems to work by the end of the quarter. However, as we said, we weren't able to properly implement it using the PCB due to different errors along the way, but we were able to get the system to work using a perf board setup. And now, we'll show an additional video of it operating properly.
Hello, this is my PCB and perf board. My name is Josh Raikin. I'm with the Workin Gherkins. Unfortunately, the PCB that I have, due to not working with my partner Michael directly, as we are far apart from each other, I wasn't able to get it to work. This was due to the last op-amp of the instrumentation amplifier not working as desired, and the PWM circuit wasn't exactly functioning very properly either. So instead, I decided to showcase my perf board and use the breadboard transmitter circuit that I had configured. I know it's messy, but due to limited time and everything, this is what I wanted to showcase. So right now, I am just putting 100 hertz out, and you don't see anything blinking or anything like that. Right now you can see when I scope the transmitter, it shows you that PWM if you look real close. But now I'm going to change this waveform to 10 hertz, which will show the beta wave, the alpha wave, which is part of the blue LED that you can see right here, and you can see it blinking. And when I put my hand in front, you can see that it stops blinking. But when I let go, it continues to blink. And I can get this to go, I think about 9 inches was, no, maybe a little more, is what I can get. So when I leave this here, and I change this to 18 hertz or 17, whatever it is, the green light, the beta filter, lights up significantly more. And if I switch this to maybe 30 hertz, you can see that this is just not really blinking or bright or anything. But if I switch it back to, maybe if I switch it to 20, then the green is lighting up significantly more. And just so you can see what this looks like a little closely with the scope, I'm going to just show you that right there. See, it's blinking with 20 hertz, and when I touch the scope to it, you can see over there that this is kind of what I'm receiving over here. See if I can get that a little brighter. It changes in magnitude. Okay, and there it is.
Alright, so this is my setup for the receiver and transmitter circuit. Currently I am running at, I don't know if you can read that, 17 hertz, and you can see the green LED is active. I'm going to change it right now to 10 hertz. Alright, so we have 10 hertz, and the red LED is now active. I am going to change it to 50 hertz, and you can see both are inactive. I'm going to change it to 5 hertz, and you can see both are inactive. And then all of this is going through a voltage divider similar to how we have it set up on the breadboard unit, and that is all coming from the analog discovery. And the perf board is powered by that 9-volt battery in that switch.